All, welcome to another session of Engineering Graphics, Semester 2. My name is Rahul Anar, Assistant Professor, Department of Mechanical Engineering, Srinarayana Institute of Technology, Adur. Welcome all. Hello students, we are going to deal with the revision classes of Module 5. We are going to study the important topics from perspective projections, basic concepts and all.
40 mm side of base and axis 80 mm long lies on its rectangular face on the ground. A triangular base is parallel to and 15 mm behind PP. The observer is viewing the object from the point 50 mm above the ground plane and 30 mm in front of PP. This is central plane is 90 mm towards the left of the axis of the prism. Draw the perspective view of the prism. Before solving this problem, let me explain some tips to find the hidden or visible edges in the perspective view. Actually, in the previous problem, we just consider a simple line. But here, it is a prism which is having more edges. Some of the edges may be hidden and some may be visible. So it is important to discuss how to find the hidden or visible edges. So the tip number 1 is boundary lines of the perspective projection are always visible. All the boundary lines of a perspective projection, perspective view are always visible. That is a rule number 1 or tip number 1. After doing this rule number 1, after drawing all the boundary lines with the visible edges, then view the top view and front view of the object from the corresponding views of station points. That is from the top view of the station point, view the top view of the object, and from the front view of the station point, you view the front view of the object. So the edge or a corner within the boundary, in the perspective view, nearer to the station point, both front view and top view will be visible and vice versa. In other way, you can say the edge or corner within the boundary of the perspective view farther to the station point in front view and top view will be invisible in the perspective view. Okay. The next tip is a line crossing a visible line in the perspective view will be invisible and vice versa. In other way, you can say a line crossing an invisible line in the perspective view will be a visible line. Last tip is all the lines joining a point within the boundary of the perspective view will be either visible or invisible. If you identify a point within the boundary is invisible, then there will be 3 lines joining to the base corner. Okay, so if you identify a base corner within the boundary is invisible, then all the 3 edges joining that corner, that point will be invisible. Okay, so these are the some tips to find the hidden or visible edges in the perspective view. Now let's discuss the problem. These are the given data. The size of the triangular prism is 40 by 80, that is 40 mm base edge and 80 mm height. And the triangular prism is resting on one of its rectangular face on the ground plane, with one triangular base is parallel and 15 mm behind PP. Because the triangular base is parallel to PP, its axis is perpendicular to the picture plane. So you can see the true shape of the base, triangular base in front view. That is your characteristic view. With that view only you can start the drawing. Okay. Then they have given the three datas to locate the station point's front view and top view. That are the distance of the observer from PP and GP, also from the object, that is central line. Central line is 90 mm to the left of the axis of the prism. In the previous problem, your station points are to the right of the object, but in this problem the station points will be on the left side. Okay, so let's begin with the ground line. And you draw this ground line at the bottom portion of your paper, then draw your horizon line. It is given that the observer is at a height of 50 mm above the ground plane. So you can draw the horizon line at 50 mm above the ground line. On this line you will get the station point's front view. Now here you can directly draw the front view of the prism, because in the front view I have already explained that point, because the prism is lying on its face on the ground plane and its axis is perpendicular to the picture plane. You can directly see the true shape of the base in front view. So because it is lying on the ground plane, one edge, one face, rectangular face, you should draw on ground line, that is A, B, 2, 1. That is your rectangular rectangular base, rectangular face. Now draw the picture plane. The distance between the picture plane and the horizon line, PP line and the horizon line, should be more than that of the distance 30 mm. It is given in the question. The observer is 30 mm in front of PP. Okay, so this distance should be more than that of 30 mm. Then you can draw the top view of the object, top view of the triangular prism. Here by drawing perpendicular projectors from A, B, C. Okay, so I have taken the triangular base A, B, C in the front side, and 1, 2, 3 in the back side. Okay, and one triangular base is parallel to PP, so you can draw this line parallel with PP line, and this base is 15 mm behind PP. It is given behind PP, so we can draw this line 15 mm above the PP. Okay, and the height of the prism is given as 80 mm, so you can complete the top view of the prism. Now we need to find the or locate the station points front view and top view. For that, first you mark the center line. Okay, this given the center line is 90 mm, center plane is 90 mm to the left of the axis of the prism. So this is your axis of the prism. So you can draw the center line which is 90 mm to the left of the axis, that is this point. Okay, now on this center line you can mark the station points front view and top view. Station points top view is 30 mm below the picture plane, that is this point, and the meeting point of HL and CL will give you the station points front view. Now in visual ray, draw the visual rays, front view visual rays and top view visual rays, and then find the perspective points. Okay, then draw the visual rays in front view first, or we have 3 visual rays here, not 3, actually it is 6 visual rays, because this is 2 points, okay, A and 1. So this visual ray represents 2 visual rays. Okay, then to find the perspective view of point A, draw the top view visual ray from S to A, and from the intercept on PP, draw a perpendicular line towards the corresponding visual ray in front view, that is S dash A dash. You will get A. Okay, then follow these steps to find other visual rays or the other perspective points. Okay, you can find B, C, 1, 2 and 3. Okay, now we consider the rules to find the visible edges and invisible edges. Here the first rule is draw all the boundary lines of the perspective points with the perspective view with the visible lines. Okay, all the boundary lines of the perspective view is visible. Okay, so you can mark these are the boundary points, so you can draw these lines with visible edges, dark visible line, dark solid line. You can use dark solid line to represent a visible edge. Okay, so AB, BC, C3, 3, 1 and 1A, these are the visible edges here, or boundary edges here. Now we have we need to draw 1, 2, 3 and 4 edges is remaining here. Okay, so let's find the visible edge and invisible edge here. Here you can see to find the visible edge and invisible edge, the second rule is view the object from the station points top view and station points front view. Okay, the line or edge which is nearer to the station point in top view and also in front view will be visible. So in this problem, AC is an edge which is nearer to the station points top view, and in front view also AC is nearer to S dash. Okay, so we can say AC is visible, so mark AC with visible edge, visible line. Okay, dark solid line. Now let's check any edge which is crossing this visible edge within the boundary. This line is within the boundary, so if a line crossing a visible edge will be invisible. You can find an edge 2B. 2B is an edge which is crossing a visible edge AC, so that will be invisible. So you got dotted line, dark dotted line. So the last rule is, if a point or a point within the boundary is invisible, then all the lines joining that point will be invisible. Okay, if a point within the boundary, no, sorry, if all the lines joining a point within the boundary will be either visible or invisible. Here this line is invisible, so the point 2 is invisible, so the other two edges 2 3 and 1 2 will be invisible. Okay. With this problem is solved.